everyone. So in this question, we've been asked to calculate the values of the marked angles, so angles A, B, and C, and then to state any theorems or angle properties that we use. So with questions like this, the best thing we can do is to label each vertex. So if we label this one A, B, C, D, and E, and we have the origin, which is the center of our circle, with marked O. So we can begin by working out this angle here. So can you see that this angle forms like a kite with the angle of circumference E? And because O to B is equal to O to D, they're both radii of the same circle, we can use the property that the angle at the center is double the angle of the circumference. So if we write then that BOD is equal to 108 degrees, the angle property we've used is the angle at the center is double the angle at the circumference. So we'll mark this on our diagram. This is 108 degrees. Okay, so if we have this angle of 108 degrees, and we know that the O to B and O to D are equal, well, now we have an isosceles triangle, which means now we can work out this angle and this angle, because these two angles must be equal. And we have angles in a triangle which add up to 180. What we'll say is O to B to D must be equal to O to D to B. The reason being is that the angles in an isosceles triangle have a sum of 180 degrees. So together, the two angles would add up to 72. So each of them will be 36 degrees, which I'll mark on the diagram here and here. Okay, so now we've got the angles in the triangle, we can use the fact that angle E to D to B, so this angle is the sum of a 26 and a 36, which gives us 62 degrees. Now can you see that the 62 degrees here will be equal to the angle A by applying the alternate segment theorem. And this segment is the alternate segment to this one. So this 62 must be equal to the angle A. So we'll say A to B to E must equal B to D to E by applying the alternate segment theorem. So again, we'll mark this on our diagram as 62 degrees for angle A. And we can apply the same idea to work out angle C. Because can you see that this angle is in this segment and the 54 is in the alternate segment? So we'll state then that C to B to D is equal to BED, this angle here, for the same reason. And again, we'll label this as 54 degrees. Okay, so all we have to work out now is angle B, but now we've got angles on a straight line. So angle B must equal 28 degrees. All we've done is 180 take away the other three known angles, okay? So we'll say that E to B to O is equal to 28 degrees because angles on a straight line have a sum of 180 degrees, okay? And we can check this works, because if we added up all the angles in this quadrilateral, we know this one will be 360 take away the 108, then these four angles would add up to 360, which they do, okay? Well, thank you very much for watching. I hope that's given you an idea on how to describe and apply the various circle theorems. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.